Hello friends, welcome back. In this tutorial we will study about how we can convert a finite automata to regular expression by using Arden's theorem. Now by converting finite automata to regular expression by Arden's theorem, we mean finding a regular expression for a given finite automata which represents its language by using Arden's theorem. If we want to find regular expression for a given finite automata which represents its language by using Arden's theorem, then that finite automata should not have any empty transitions. Now see, suppose this is a finite automata whose initial state is Q0 and its final states are Q1 and Q2. Now what we have to do? We have to find the regular expression which represents its language by using Arden's theorem. Right? It means we have to find the regular expression for this finite automata which represents the set of those strings which drives this finite automata from its initial state to any one of its final state. So what we have done, we have associated a regular expression with each state of this finite automata. Q0 is associated with state Q0. Regular expression Q1 is associated with state Q1. Regular expression Q2 is associated with state Q2. Now, what these regular expressions signifies? Qi is the set, is the regular expression. Here Qi is the regular expression which represents the set of those strings which drives the finite automata from its initial state to Qi state. Right. Now see this. Regular expression Q1. Now, when the machine is in state Q0, on reading an input symbol, it jumps to state Q1. Right. Here Q0 is a regular expression which represents the set of those strings which drives the machine from initial state to Q0 state. Here Q0 is the initial state. So when the strings of regular expression Q0 is concatenated with input symbol 0, then that string will drive the machine from its initial state to Q1 state. So we can say Q1. So the regular expression Q00 represents the set of strings which drives the machine from initial state to Q1 state. Similarly, see, when the machine is in Q2 state and it reads input symbol 0, then it jumps to Q1 state. Now, when the strings of regular expressions Q2 are concatenated with input symbol 0, then the strings which we get after concatenation will be the strings which will drive the finite automata from its initial state to Q1 state, because the strings of regular expression Q2 drives the finite automata from its initial state to Q2 state. Right. So similarly, in case of when the finite automata is in state Q1 and it reads an input symbol 1, it jumps to state Q1. Right. So Q1 1. This regular expression also represents the set of strings which drives the machine from initial state to Q1 state. So Q1 equals to Q0 0 plus Q1 1 plus Q2 0. Now see this initial state Q0. Now see, regular expression empty also represents the set of strings which drives the machine from initial state to Q0 state, because Q0 is the initial state of this finite automata. So even if we don't apply an input symbol, machine will stay in Q0 state. It means without reading any input symbol, machine will jump from its initial state to Q0 state. Now see, when the machine is in Q1 state, right, and it reads an input symbol 1, it will jump to Q0 state. So the regular expression Q1 represents the set of all strings which drives the machine from initial state to Q1. When the strings of this expression Q1 are concatenated with input symbol 1, then the strings which we get after concatenation will be those which drives the machine from Q0 state, from Q0 initial state to Q0 state, right? So similarly, Q2 will be equal to Q10, Q0 equals to empty plus Q00 plus Q11. Now see, here in this finite automata there are two final states, Q1 and Q2. So its language of this finite automata will be represented by the regular expression Q1 plus Q2, right? Because Q1 regular expression represents the set of all strings which will drive the finite automata from its initial state to final state Q1, and Q2 will represent the set of all strings which drive the finite automata from its initial state Q0 to final state Q2. So the language of finite automata can be represented by this regular expression Q1 plus Q2. Now see, what is the Arden's theorem? If P, Q and R are regular expressions and P doesn't contain empty string and R equals to Q plus RP, then R equals to QP clean, right? Now we have three equations. What we have to do? We have to find the value of regular expression Q1 plus Q2 in terms of input symbols 0 and 1. So what will we do? We will solve these equations by repeated substitution and by using Arden's theorem. So what will we do? First, see, Q2 equals to Q1 0. So what will we do? We will put the value of Q2 in equation Q1. So when we put this value of Q2 equals to Q1 0. It means when we replace this Q2 in this equation by Q1 0, then the equation will become like this: Q1 equals to Q00 plus Q11 plus Q100. Now take Q1 common in these two expressions, right? When we take Q1 common, then it will become Q00 plus Q1 1 plus 00. Now we can apply Arden's theorem here. By applying Arden's theorem, we will get Q1 equals to Q00 1 plus 00 clean, right? Now put this value of Q1 in this equation Q0, means replace this Q1 by the right hand side of this equation, right? So when we put this value of Q1 in this regular expression, then what will we get? We will get Q0 equals to empty plus Q00 plus Q00, right? Q00 1 plus 00 clean and 1, right? Now we can take Q0 common in these two expressions. When we take Q0 common, we will get empty plus Q0. In bracket there will be 0 plus 0, 1 plus 0 0 clean 1. Now see, by applying Arden's theorem, what will we get? We will get Q0 equals to empty string in bracket 0 plus 0 in bracket 1 plus 0 0 clean 1 clean, right? Now since empty and when empty string is concatenated with regular expression R, then it is equivalent to regular expression R. So it will be equal to regular expression 0 plus 0, 1 plus 0 0 clean 1 and the whole clean, right? Now put this value of Q0 in this equation Q1, right? When we put this value of Q0 after removing this empty string, right, in this Q1, what will we get? We will get this expression Q1 equals to 0 plus 0, 1 plus 0 0 clean 1 1 clean 0, 1 plus 0 0 clean. Now put this value of Q1 in Q2. Q2 equals to Q1 0. So what will be the Q2? Q2 equals to this value and then 0, right? Now see, we have to find Q1 plus Q2. When we add Q1 plus Q2, when we find Q1 plus Q2, then what will happen? This portion is common in this expression is common in both regular expression. So when we take this common, what will we get inside the bracket? Empty plus 0. So Q1 plus Q2 will be equal to this regular expression, and this is the required regular expression for the given finite automata. Thank you very much.